Hello everyone, welcome to my YouTube channel. This is Filipino explaining OR gate. OR gate. OR gate is what we are going to look at in this video. Before I start explaining, please, if you are new to my channel, please make sure you do subscribe and don't forget to click bell notification. Thank you. Okay. OR gate is one of the types of logic gate. The gate is this logic gate, OR gate, is an electronic circuit that gives a high output if one or more of its inputs are high. When I say or I mention high output, when dealing with logic gates, high output, we assign it to 1, and low output, you assign it 0. So the OR gate, as I have said, is that an electronic circuit that gives a high output if one or more of its inputs are high. It has a plus, and this plus is used to show the OR operation. OR gate looks like this. This is an OR gate. Z is the output. Then you have these two inputs. In this case, we have two inputs, X and Y, at the input. Then Z is the output. And the output, Z, is the binary sum of the inputs. It's the binary sum of the inputs X and Y. And you can therefore represent this as X plus Y is equals to Z. Have the truth table for OR gate. Truth table. We have two inputs, and I've said the inputs are X and Y, which implies 2 raised power 2 is equal to 4 henries. 4 henries. Remember, the truth table is used to show how the function of a logic gate. The truth table is used to show or to help show the function of a logic gate and the relation between outputs and inputs. You can see from this, you have two inputs, and I have written 2 raised power 2. Why 2 raised power 2? I mean the number of entries on the table is 2 raised power n. 2 raised power n, where this n being the number of entries, the number of entries and base 2 because it's related to the binary numbering, and the binary numbering is 0 and 1. So 2, the base 2 is because it's related to the binary numbering, and n is the number of entries have two inputs x and y, so it is 2, n is 2. Are we there? So you can draw a truth table here. You have x, y as the inputs, then z as the output, z as the output, z as the output. So remember, I have said that Boolean variables are 0 and 1. So the inputs can be all of them, or both can be 0 0 0 0. They can be x can be 1, can be 0, y can be 1, x can be 0, y can be 1, x can be 1, y can be 0, and the both x and y can be 1 1. Are we there? So I have said that the output of an OR gate is the binary sum of the inputs, and that's why I have written this, that x plus y is equal to z. So the output z, we shall add this 0 0 to get z, 0 1 to get z, 1 0 to get then 1 1 to get z. When x is 0, y is 0, what is z? When x is 0, y is 1, what is z? When x is 1, y is 0, what is z? And when x is 1, y is 1, what is the value for z? So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. Are we there? So equivalent circuits, when x is 0, y is 0, z is 0, so the equivalent circuit will be this way. Here S2, this switch 1, switch 2, here is a bulb. So that's when x is equals to I can write with this, x is equals to 0, y is equals to 0. When x is equals to 0, y is equals to 0, therefore we can imply Z is equals to 0. There's no light, as you can see. Okay, let's look at an equivalent circuit when x is equals to 0, y is equal to 0, and therefore y is equals to 1, the second one, sorry, y is equals to 1. This implies that z will be equals to 1. Z is equals to 1. Z is equals to 1. So an equivalent circuit is 5 voltage, you can see that switch 1 is open, then switch 2 is closed, meaning if you take switch 1 to be for x 0, then this for y1, then the bulb will give light. So there's light. Remember, I have said that OR gate gives a high output if one of the inputs are high. So when x is equal to 0, y is equal to 1, 0 is low, is low, the input x is low, y is high. So one of the inputs are high, so it gives a high output, which is 1. Are we there? Another equivalent circuit when x is equal to 1, y is equal to 0, therefore z will be equals to 1. When x is equals to 1, y is equal to 0, z will be equal to 1. I'm just sketching. 5 voltage. This is switch 2. This switch 1 is the one that is closed. Switch 1. So have the valve here. So there will be light, there will be light. Are we there? There will be light. And then the last one, when x is equals to 1, y is equals to 1, z is equals to 1. So both the switches, all the switches will be closed. In this case, all the switches will be closed. All the switches will be closed. Yeah. 5 voltage. Switch 1, switch 2. Gives high output. High output. Remember, here is for this is 0 plus 0 is equals to 0. For this one, it is 0 plus 1 is equals to 1. For this one, it is 1 plus 0 is equals to 1. Then for this one, it is 1 plus 1 is equals to 1. And up that point, I hope that we are through with the OR gate. Thank you so much for watching. Bye bye.